So question number 3E on the rational exponents worksheet. We have here two radicals are being divided with, but one has an index of 4 and the other one has an index of 3. So this is a bit of a problem. We need to have compatible indices to be able to do this. So an easier way to maybe approach this problem is think of this problem as an exponential problem. And we can convert this into exponent by using power 5 in the numerator, power 4 in the denominator. And in the bottom, we have power 5 in the numerator, power 4 in the denominator. And we can apply exponent rules to this then. So we have divide, so we're going to subtract those powers. So we're going to have 5 over 4 minus this is going to be 5 over 3 in the denominator, isn't it? So that's going to be a 3. So we're going to have 5 over 4 minus 5 over 3. Now, if we're going to subtract fractions, we need a common denominator. And so if I want a common denominator, I'm going to multiply the top and bottom of the first fraction by 3. So times 3 times 3. And then I'm going to times 4 times 4 for this fraction. Okay, so then what I end up with is then x to the power 15 over 12 minus 20 over 12. And then that gives me my answer of x to the power of negative 5 over 12. So that would be one way to do it. Now, an alternative way to do it is to think of it slightly differently in that the root and the power can be powered up the same because it's a ratio. The root and the power form a ratio. As long as the ratio stays the same, the value of that radical still stays the same. So I can rewrite, instead of a 4 to 5 ratio of root to power, I'm going to do this as a 12 to 15 ratio. And that's going to give me an index of 12. And I'm going to do this similar thing to the denominator. I'm going to power the 3 and the 5 up to a root 12 and power 20. What that does then is it gives me a common index, and that allows me to just rewrite this all under one index, x to the power 15, x to the power 20, and this gives us index of 12, 1 over x to the power 5. So these are the same answers because the negative indicates that we have a divide. The index of 12 shows up as a denominator of 12 in the exponent, and the power 5 shows up in the numerator of that exponent. So in fact, these are the same solutions. One is in the radical perspective, but the other one is in the power perspective. But in both cases, it is good to recognize that getting this common index of 12 is the same process as getting a common denominator of 12 in the powers when we subtract the powers here.